Okay, so again, I'm continuing to show you more illustrations. This one I'm going to show you is number 26 from your textbook. And this one, we have to use the table a little bit differently. So this one is the SAT score. It's a standardized test. They tell you that the average score is a 1500 with a standard deviation of 300. They would like to offer an honor scholarship for students who are in the top 10% of the test. Okay, they want the minimum score to be in the top 10%. So to give you my visual, I'm going to go ahead and draw the curve over here. All right, and it says top 10%. I'm going to shade an area under the curve, the upper part of the curve, and that's basically the top 10%, and I'm going to label that as 0.10. I like to use decimals. All right, now I'm going to take my curve again like I've been doing. I'm going to divide it in half and remind you that 0 is always in the middle. All right, now if I look at this particular table, I'm going to be looking for areas under this curve to find a z-score. If I can get this particular z value, I can then convert that into x. So if I want to know from, for example, 0 to this particular z value right there, if you look at the complement, I know that that's 0.40 because 0.4 plus 0.1 gets you to 50%. So if I go to this table, I'm looking in the body of the table. Look at the body of the table. I'm going to try to find 0.40 in the body of this particular table. So as I'm looking, the closest number that I'm going to find, guys, looks like it's right about there. All right, that's close enough. It's not exactly 0.40, but it's 0.3997. So if I do that, notice that's correspond to a z-score that's right about 1.28. So I know that this z-score is 1.28 from 0 to this is 0.4. Now obviously to the right of that it's the same z-score, it's still 0.10. So you kind of have to use the complement rule to figure out, okay, what particular area am I going to look up under the curve. So if the upper area is 10% and from 0 to z is 0.4, because that's the complement, I looked up 0.4 and I'm estimating it's right about there. So I'm saying the z-score is 1.28. You could also say that's the same corresponding to an area to the right of it that's right at 0.10. So now that I've got my z value, I can go to my equation. Z is equal to x minus mu divided by sigma. I'm going to plug it in. So I'm going to take 1.28 equals x, which is my SAT score, minus the mean, which they said was, what, 1500. And I'm going to divide that by, it looks like the standard deviation was, covered up, I think it's like 300. And then there's your equation. So you cross multiply. So you take 300, multiply that by 1.28 equals x minus 1500. And then of course you add 1500 and the final answer is right at 1,884 would be your final answer. So that's how you basically would use a percent to get the area, then to go backwards essentially to look up a z value and then plug it into your z equation to solve for x.